General properties of wave. You're welcome back. General properties of waves. First, we would like to find what wave is. Wave is a way of moving energy from one place to another caused by a disturbance or a vibration. Waves are made up of repeated vibration oscillation. Do you have an idea of what vibration is? Yeah, you can feel free just. Yeah, you can talk, no problem. What vibration is?
Yes.
Oh, you have an idea. That's good. Okay, so by vibration, what do we mean?
The movement of particles.
Movement of particle. Of movement of something, maybe back and forth or up and down, that's vibration. Okay, so when something vibrates, then energy travels or energy is transferred. Okay, so the transfer of energy that is caused by something that vibrates is actually wave. For instance, when my vocal cord vibrates, it leads to the air vibrating, isn't it?
Yes.
And there's a kind of energy that travels to your ear, which is known as sound energy, isn't it?
Yes.
What causes the different types of waves? Or what causes the disturbance? For sound wave, it is caused by something vibrating, causing the air around it to vibrate. For water wave, the vibration is actually caused by an object, exactly, thrown inside water. For ocean wave, the vibration is caused by friction between the surface of the ocean and the wind, like you have in this case. Okay, and for waving a string, like in a rope here, it's caused by you moving the rope up and down. That's a vibration. Okay, for light wave is a special kind of wave. It's called an electromagnetic wave. The vibration is actually caused by a changing magnetic field, which then leads to a change in the electrical field. Okay, pulse, these are pulse or signals, and then our light tend to travel or transfer when this vibration happens. Magnetic field vibrates, causes a change or vibration in electrical field. Okay,
Yes.
for waving a slinky spring like this, look at this, a slinky spring, like a yo-yo spring. When you push it back and forth, it can, that's the vibration. Okay, can lead to transfer of wave.
Yes.
Features of wave. Features of wave are things that you can find in any wave. If this is a wave, water wave, what are the things, the stuff you can find? Like, what is this top called? What is this bottom here called? Okay, the top here is called the crest or the peak of the wave. Look at it, it's the peak of the wave or the highest point of the wave. So we have a highest point here, we'll have a highest point here, we'll have a highest point here. Okay, look at this water wave. Can you see? This is the highest point, isn't
The
it?
crest.
It's a crest. This is the highest point. There's a highest point. Several highest points. They are called the crest. Now the distance from one highest point
To the other
to
is
the
wavelength.
other, one highest point to the other highest point is called the wavelength. Get it?
Yes.
Why the amplitude is the height of the wave from the center position. How high is a wave like? See a wave formed here. How high is a wave? That's a. But you have to like create a center position
Teacher,
between
but
two
for
marks.
here, if they didn't give us the line and they said find the
The amplitude. Yeah, you have to draw the line.
on, like, I have to have it.
Yeah, you have to have it. You see, like this is the top. This is the top of this wave, isn't it?
Yes.
And this is the bottom of the wave.
Yes.
So it's like you're going to create a half between the top and the bottom.
Oh.
Yeah, like this. You're going to create a half between them, half it. Then the amplitude will be from the center, that point where you create the half. Like you're dividing them into two parts. To the top, Good? Yeah, that's the amplitude of the wave. There are other features too, like the trough. Trough, look at it. That's the bottom. You call it a trough. Okay?
Yes.
Now, a wave front is actually the pattern of the wave. Maybe the next slide will help us to know better. It's a wave front. This is a wave front, this is a wave front, and this is a wave front. See, if you look at this wave front here, it's like a straight line, straight pattern.
Yes.
Can you see? But this one is like a circular pattern, right?
When you drop
Yeah, you
it,
drop something in water, it forms circular bands. So that's the circular wave front. But this one that is straight pattern, we call it a plane wave front, like
what is
this.
this?
Which one? It's something that is creating the wave. It has to vibrate. See the vibration here? It's vibrating, and otherwise the water wave will not be produced. This is the
Yes,
water.
even if you want to make waves in the pool, you can get a floaty and do it up and down.
Yeah, of
up and
course.
down.
Yeah, but once you get a floaty, do it up and down. You have to vibrate something for waves to start traveling. Otherwise, it won't travel. Okay, but there's something you need to know about the wave. The particles don't actually move; they just vibrate up and down. It's a wave that moves. The particles still remain in a fixed position. Anyway, when we get to the next other slides, you get it better. Good.
Yes.
Now, waves can be classified by direction of vibration, by how they vibrate. We can classify wave as transverse wave and as longitudinal wave. I think you did this in year 8.
Yes.
Yeah, so transverse and longitudinal wave. Basically, this transverse here is just how it vibrates, transverse direction. It vibrates up and down.
Oh yes, I remember we did it.
Okay, so a wave in which the vibration is up and down is transverse wave.
And longitudinal
Longitudinal,
is like just like that.
back
long.
and forth. Yeah, from the word long, longitudinal. So it's back and forth kind of vibration,
Yes.
right? Okay, but the whole waves are traveling in the same direction. Notice that they are all moving towards the right hand side. Did you notice it?
Yes.
So the waves are moving this way, but the vibration producing it are different. For transverse is up and down, for longitudinal is back and forth.
Yes.
Good? Like this. This vibration is what? Up and down or back and forth? Which one? Is it up and down or is it back and forth?
Up and down.
Good. So what kind of wave will be produced?
Transverse.
Transverse wave. Very good. See, but up and down, up and down. Notice what's happening to the particle. Did you see the particles moving?
No.
They are just going up and down. This is exactly
they're
what
just
happened.
like
Just going up and down, right?
they're
Up and
staying in
down
their place.
in the fixed position. That is exactly what happened to the particle. They stay in a fixed position, but they only vibrate up and down while the wave travel towards the right hand side. Okay?
Yes.
Now let's observe this and see.
Yes, you showed us this.
I showed you, right? Okay, just fix your eye on the white
White dot.
dot and see what happens to it.
Up and down.
Up and down. This shows that the particle doesn't move. It's actually the wave that does move. The particle just keep vibrating up and down, right? Examples of transverse wave. We have the water wave or water ripples. We have the light wave. Examples of transverse wave. We have the water ripples, like what you have here. Now notice that when you drop something, when you put something in water and creates a wave, the thing goes up and down. The object will just keep going like this, up and down, up and down, up. That's telling you how the water is vibrating. The particles in the water is vibrating. That's a light wave. Light wave, it's hard for you to determine if it's how the vibration happens, but there's something called a Polaroid to help to determine the vibration. Okay, now the vibration is actually caused by two signals, magnetic signals, which also creates an electric signal, changing magnetic field that causes a change in electrical field. You won't be able to notice this until you use a Polaroid. A Polaroid will help you to be able to find out how it vibrates. So the lesson about polarization is beyond your level at this stage. There's a wave in a rope. It's also a transverse wave because you have to move the rope up and down
Yes,
like this.
and the slinky.
Yeah, and the slinky spring, depending on how you're moving. If you're moving up and down, it creates
Yes, or
transverse
like
wave.
this.
If you're moving back and forth, it creates a different kind of
Yeah.
wave. earthquake, we have the S wave, seismic S wave. The earthquake produces two waves, the P wave and the S wave. The S wave is a secondary wave. Okay, it actually vibrates uh, up and down, or back up and down actually. Okay, so that's what actually causes some of this landslide and all of that, is because of the S wave. The other one, which is the P wave, is longitudinal. It doesn't cause much damage like this.
That's why
Then,
quickly when there's an earthquake, you see all cracks in.
yeah, that's the
Yeah.
cause. The cause of the crack is a wave. This wave, the S wave, the one that it causes the earth itself to move up and down, and then the vibration will be, of course, is too much, so it causes a lot of cracks and that, all of this. Now we have the electromagnetic wave. Light is part of this family of waves, like the radio wave, the microwave, the gamma ray, so on and so forth.
Yes,
They all belong to this family. Even the infrared waves,
yes.
yeah, they all belong to that. They are all transverse waves. You can see we have a lot of
Ishan,
transverse
what is
waves.
this?
This is like a rope, like a string. It creates a wave pattern.
It
on the ground.
represents this rope.
Yeah, it's representing the rope. Yeah, here you're moving it like this way, like you're moving it front, back, or right and left, right and left. You're creating the wave. Now, what are the parts of a transverse wave? Already, the parts of the transverse wave are also parts of a general feature of a wave,
Yes.
normal wave, that you know. Like first we have the
Crest.
peak or the crest.
Crest.
That's the top. We have the trough. That's the bottom. We
Teacher,
also have,
If you want to remember the name of this,
yeah,
just remember the edge of the pizza is a crust. So this is a crust.
really? Oh, that's good. So you guys can also actually develop a lot of ways to remember stuff. Then the wavelength. The wavelength, you know it already.
Yes.
Distance from where to where?
From the two highest crests.
Good, very good. Now, or the two highest straw. Okay,
Yes.
the two lowest straw rather. The wavelength can also be from one end of one wave to the next end to a similar point in a wave. One point in a wave to a similar point in a wave. Okay, but this one is a little bit confusing. You can use the crest, one crest to another crest. Good?
Yes.
We use the symbol lambda, this symbol for wavelength, but don't worry about it. You don't need it. Just know the wavelength, what it means. Now, the amplitude of the wave. The distance from the center of the wave to the
To the
highest
crest.
point, which is
To the
to the
crest.
crest. Yeah, of course, that's it. Or distance
Or
from
from
the center to the trough, the lowest point. That's the amplitude. Good?
So the highest is the crest and the lowest is the trough.
Yeah. So we have the next, which is frequency. Frequency is the number of waves passing any point in each second, in 1 second. How many waves passes a point? Here we have like how many waves? We have one wave,
2,
two waves,
3, 4.
three waves, four waves. Okay. Now you can even count the peak. 1, 2, 3,
Three,
4.
four.
But make sure the trough is also
But from
Four
the trough is
also.
1 or 4.
4. So if it's the same, if it's the same, that means we have 4 waves. Good?
Yes.
Yeah, so one wave traveling per second is called 1 hertz. So for 4 waves traveling, we will give it 4 hertz. If you have 4 waves, then you say 4
Oh,
hertz.
yes.
So hertz, it's a unit for frequency. How many waves is traveling or passing through a point in 1 second? If it's 1 wave, 1 hertz. But if it's 4 waves,
4
4
hertz.
hertz. If it's 10 waves,
10
10
hertz.
hertz. What do longitudinal waves look like? They look like this. We can demonstrate longitudinal wave using a slinky spring that you move back and forth. Look at this slinky spring. When you move it forward, it creates a region here. Can you see it? Compression region. When you take it backward, it's like you're loosening it up. It creates a region, refraction region. Can you see as you're moving the slinky spring, 2 regions are automatically formed.
Yes.
Did you see this region? And wave travel. wave travel. What's the direction of the wave? Right or left?
Huh?
Direction of the wave.
Right.
Right. What's the direction of the vibration?
Left.
You sure?
Right.
Sure? Right and left. So when you have right and left, you can say back and forth, or front and back.
Back.
Just take it front and back, back and forth, whichever one suits you. Okay, what are the parts of a longitudinal wave? These are the parts. We have the compression, we
Refraction.
have the refraction.
Yes, I remember. Compression is like they're compressed.
Compressed
Refraction
together.
like that.
They're loosening up, loosened up.
Yes, we did in your 8.
Yeah. So the compression region is a high pressure region where you have a lot of pressure. It's like things are being compressed together.
Yes.
While the refraction is a low pressure region, less pressure.
Compress.
Okay.
Right.
The highest compression is at the middle. Look at it. Even though these ones here are compressed, the highest compression is in the middle. This one also, even though all of this is they spread out, they separate, the high separation is in the exactly in the middle. That's where you have the highest refraction. The P wave, which is a primary wave of earthquake, is similar to this kind of wave, similar to longitudinal. In fact, it's a longitudinal wave. So it does like this Linky spring. Now, a sound wave is a longitudinal wave. And this is a small demonstration of what happened to sound wave. If you look at it, it looks as if the particles are moving. But set your eye on this red one and notice what's happening to the red dots.
Oh, it's staying in its place.
Yeah, it's going just
Back and
back
forth.
and forth. That's how a particle of air vibrates when you make a sound. When the speaker makes a sound, you know it's making
Yes,
a
it used to do
boom,
pa-
forward
pa-
and
pa-
backward, forward and backward. As it's pushing the air forward, it creates a compression region. As it drags itself backward, it creates a refraction region.
These are eardrums. These are the mini burns. Coilia.
Yeah, that's cochlea. Anyway, we'll get to that point. So the energy is what transfers to the ear, true or false?
Yes.
The particle only vibrates,
Yes.
but the energy travel and get to the ear. Okay, because you know everywhere is like filled with air, including the ear. Everything is just vibrating. So this vibration, when it gets to the ear, is passed. That is dictated by the eardrum, which also vibrates in sympathy with it, right? The same way it's vibrating. And the vibration is passed along to these ear ossicles here, the tiny ear bones. The tiny ear bones, they transfer the vibration to this cochlea, and then there's liquids there. Liquids inside this cochlea that
Yes.
also vibrates and then transfer the information to the nerves that are connected or attached to them, which takes the information form of electrical signal to the brain. So this happens very fast, super fast, and then you're able to process the information that someone is saying
Yes.
and give a feedback
But it works very fast.
very fast. So that's how it works. That's sound
Teacher.
wave. So two regions are also formed in sound wave. You want to ask a question? Go ahead.
No, the fireworks,
Yeah,
it used to hurt the ear.
because the sound is much.
Yes.
Yeah, that's why you shouldn't expose yourself to sounds that are beyond certain
Or on your
decibel
phone,
scale.
if you hide the volume too much, they will tell you this may cause ear damage.
Yeah, because the sound is bigger than the value of the sound, or the decibel of the sound is beyond what you should allow in your ear often. All right, so let's continue with this. Notice this is a demonstration of longitudinal wave, how sound behave. You will see that at a point, forward vibration causes compression. Can you see it?
Yes.
Backward vibration causes refraction. And the compression of one passes along to others. It's like this will bump on this, compress
Yes.
it, and then
And gave it to the
gave
other.
it to the other one. That's how I keep transferring. But notice what happens to the particle. The particle don't actually move. Set your eye on this.
It only goes on back and forth, back
Yeah,
and forth.
put your eye on this white dots, back and forth, right?
Yes.
Okay, that's exactly what happened to sound wave. Good. So sound wave is longitudinal. Examples of longitudinal wave are the sound wave, the seismic P wave, the slinky spring move back and forth like this. These are examples. Sound wave doesn't have much example anyway. Yeah, I just have to know these ones. Longitudinal wave rather doesn't have much example. But one of the most popular example here
Sound.
is sound wave. And
Teacher,
Linky spring
if I
is
don't-
used to demonstrate it.
If I don't remember seismic P wave, I can
Just
write,
as simple as P wave.
or I can write P wave with bracket earthquake.
Yeah, it's okay. It's good. Wavelengths of longitudinal wave. The wavelength of a longitudinal wave is simple. Very simple. From the middle of the compression to the middle of another compression, that's wavelength. Or from the middle of the refraction, we have the highest opening, to the middle of the
Yes.
other refraction is a wavelength. Now, this is, you can also demonstrate it, put it in form of lines. This is quite easy to remember if you're putting lines.
Yes, compression is
Where the
compressed.
lines are together,
Refraction are
where
far
the
away
lines
from
are
each
far
other.
apart. And this is the direction of the movement, right?
Yeah.
Okay, let's compare. You can see the pictures here comparing everything. So let's not waste our time on this. We've already done that. Now, wave property. Wave property is what is common to all waves. Light wave, sound wave, water wave, P wave, S wave. It's a property that is common to them.
Yes.
Okay. One of the properties is reflection. Reflection. It's common to all. Another one is refraction. We'll talk about them later. Diffraction. This one is caused by gap. When there's a gap that the wave is forced to pass through, it's going to cause diffraction. But then you go to know what's diffraction. And then this is interference. Interference is simply how when wave add up or cancel out. Okay, there are other properties anyway that are not here. That's polarization, but that happens only in transverse wave. And other properties that are not here. We actually study this property using this item here. It's a ripple tank. Call it a ripple tank. A ripple tank helps you to be able to see what's happening, especially in water wave. You can set up a plain water wave by having a straight object to vibrate on the water, or you can set up a spherical water wave by having something like a straight becky object like this to hit on the water up and down, up and down.
Oh yeah.
Okay, that will create a spherical wave. And then you can study the pattern and see how it behaves. Good. On one study, a wave traveling forward in a ripple tank hits an obstacle and bounce back. What can you call it? Traveling forward, hits an obstacle and bounce back at the same angle. What can you call it?
Vertical surface. Reflection.
It's similar to reflection of light.
Yes.
Yeah. So light is of course a wave too, so it reflects. So light is quite easy
Teacher,
to
but it's
absorb.
easier to
Observe
travel
light.
through light than travel through water.
Yeah, to absorb light
Yes.
than water. Water, you have to be careful and see how the bands. It's not just you're going to see the wave fronts moving and then hits this and move. But light, you can just use your light, you touch light, shine it on the mirror, and then you see the reflection quickly. That's reflection of wave. Okay, it happens in all wave. But this case, we're just studying.
Yes, I
one
remember
wave.
those ones.
Look at it. Look at it. Look at it. This is a demonstration. A wave moving this way, hit something, and then move towards the other end.
Yes.
The angle of incidence and
Yes.
reflection, they're always the same.
I forgot everything.
Okay, so it's similar to what happens in light wave. The one that hits the barrier is called the incident wave, like this wave there.
Refracted
The
ray.
one that go away from the barrier is called the reflected wave.
Yes.
For light, you call it incident ray, reflected
Refracted
ray. Okay, okay. Let's move next. Next is a wave in the water in a ripple
I always
tank.
get confused reflection and refraction.
The reflection is bouncing back. Refraction is quite different. Refraction has to do with the speed decreasing and the direction changing.
Oh, like those people marching on sand.
Yes.
Oh, okay, yes. I
On a
remember.
normal ground, and when they get to a sandy ground, there's
They
no way
slow
your
down.
speed will be the same. And sometimes you can even shift your position from where the angle where you're marching from.
Yes.
Okay, so if a wave, water wave for instance, in a ripple tank get to a point that is shallow, this is deep, and this is shallow. You know how what happens? It changes direction.
Yes.
It actually first it changes speed. The speed is going to change. If the shallow object is placed at an angle like this, same here, it changes direction too. Now, what do you notice about the gaps? The gaps represent the wavelength. The gap here and the gap here. What do you notice?
This one is compressed.
And this one
This
is
is
bigger, right?
refraction.
So it means the gaps, the wavelength here when it changes is smaller than the wavelength before it changes. Okay, but don't worry about that. Just know that when a wave is traveling from water wave is traveling from a deep region to less deep region to a shallow region, the speed changes and the direction can even change. Good. Okay, now the last one for interference, I'm not going to talk about it here. It's a topic on its own. The last one is when a wave is traveling straight, plane wave, and encounters an obstacle like this, a gap, it spreads out.
But when the hole is bigger,
Yeah, it doesn't spread as
Yes.
much. The best spreading can be obtained when the gap is the same thing as the wavelength of the wave. I mean the gap, the distance between these two lines from one wave to another and the distance of the gap, when they are the same, you get the best refraction like this. This is one of the best, diffraction. This is one of the best diffraction you can get. So curved out very nicely. But when the gap is too much, did you see how it's curved?
yes,
Not too nicely.
like it's almost straight line.
Yeah. This is called diffraction. Don't forget, diffraction. These are other pattern of diffraction, other cases of diffraction.
It's very easy.
Yeah. You have any question? Like, share, and subscribe.
Right.
Thank you for watching.